All right, let's just jump right in. Imagine you're a coder, you're staring at a blank screen, but your job today isn't to build another app. No, your job is to write a script that can actually validate a new theory of everything, a program that's designed to put our entire understanding of the cosmos on trial. Well, today we're going to look at a project that does exactly that. I mean, think about that for a second. This is basically the ultimate unit test for the universe. We're talking about a piece of software that grabs real, messy astronomical data, observations from galaxies, cosmic radiation, and then runs it against a completely new set of physical laws. This isn't just some abstract theory, this is cosmic validation, line by line of code. So, at the very heart of this whole thing is something called the QAG nexus. It's this incredibly sophisticated automated data comparison and validation tool. Honestly, the best way to think about it is like a continuous integration pipeline, but for physics. It was built by a researcher named Rodney Ripley Jr., and it was designed for one incredibly ambitious purpose: to rigorously test a radical new theory against the hardest astronomical data we can possibly find. Okay, so why would anyone go to the trouble of building a tool like that? Well, it's because modern physics has a huge, dark secret. For decades now, cosmology has been staring down what some people call an epistemological crisis, which is really just a fancy way of saying we're not even sure if we're asking the right questions anymore. Our best description of the universe, the Standard Model, well, it's got some massive holes in it.
Yeah, you're seeing that right, 95%. According to our current model, 95% of reality is made up of these mysterious, invisible fudges, things we call dark matter and dark energy. These are things we've never ever detected, but we had to invent them just to make the math work. And that's not just a scientific problem. It's a philosophical one. It basically screams for a totally new approach.
And that new approach, it starts by basically reframing the entire operating system of the universe. The current model, it kind of sees the cosmos as this dead, random machine, just stuff bumping into other stuff. But the QAG framework, it proposes something completely different, that the universe is a living, resonant system, where every single part is trying to achieve maximum coherence with every other part, not just a collection of objects, but a vast, self-optimizing network. Now, a new philosophy is one thing. That's great. But how do you turn that into actual testable science? Well, you treat it like any other system with rules. You try to find its source code. And that's where quantum affinity gravity, or QAG, becomes way more than just an idea. It becomes a framework you can actually program and validate. So here's the core paradigm shift. In standard physics, we're taught mass creates gravity, right? A bigger object has a bigger pull. Simple. QAG totally flips that on its head. It says gravity is an emergent effect of a much deeper drive for systems to connect and synchronize, to find affinity. Think about two tuning forks. They just naturally want to vibrate at the same frequency. QAG suggests the entire universe works just like that, and that mass is just a side effect of an object's internal harmony. And this brings us right back to the build. With a whole new set of physical rules, you're facing the ultimate challenge. How do you prove it? You don't just write a paper and call it a day. No. You fire up your IDE and you build a high-fidelity validation engine to run the numbers against reality itself. And look, this isn't some toy project running on sample data. The QAG Nexus is a serious piece of engineering that automates data collection from the world's top cosmological surveys. We're talking Spark, which gives us data on how fast galaxies are rotating. There's Planck, which has a snapshot of the universe's baby picture, the cosmic microwave background, and the Dark Energy Survey, DES, which maps the large-scale structure of the cosmos. This is a direct head-on confrontation with real-world observation. Now, here's the part that I think is just so cool, especially for us developers. Look at the toolkit. This cosmic validation engine is built with Python. It's using NumPy and SciPy for all the heavy-duty physics calculations, Pandas to wrangle that astronomical data into clean data frames, and Matplotlib to visualize the results. These are tools that millions of us use every single day, and here they are, being used to tackle the biggest questions in science. It just proves you can do amazing things with a solid grasp of the fundamentals. Okay, so let's get to the results. The engine's been built, the data pipelines are hooked up, now it's time to put the standard model and QAG head-to-head. It's time to put the universe on trial. And the results, well, the source material calls it a grand slam. The QAG Nexus shows the theory doesn't just solve one problem. It resolves 6 of the biggest, most puzzling, and previously unrelated problems in physics. Everything from why galaxies spin faster than they should to the Hubble tension, which is this major disagreement on how fast the universe is expanding.
The QAG framework provides a single, unified solution for all of them, and it does it without inventing dark matter. And this right here just brilliantly illustrates the tool's predictive power. So on the left, you see the code generating a ghost halo of gravity using only normal baryonic matter. That's just the stuff we can actually see, like stars and gas. And it perfectly explains galaxy rotation. Then on the right, it resolves something called the S8 tension, which is basically just a measure of how clumpy the universe is. QAG correctly predicts a smoother universe, which is exactly what we observe. It's mimicking the effects of dark matter without any dark matter at all.
And the numbers? Well, the numbers are just demonstrably better. The software analyzed a galaxy called DDO-154, and the results are pretty striking. It uses a statistical measure called chi-squared. You can just think of it as a badness of fit score, so a lower number is way better. The standard model, it scored a whopping 228. The QAG nexus, just 19.4. That is a 6.6 times better fit to the actual observed data. The code doesn't rhyme.
Okay, so the validation is, well, it's pretty compelling. But if this new model of the universe really holds up, what does it mean for us? What kind of future does this living universe actually unlock? This is where it gets really wild because it moves from theoretical physics to a literal engineering roadmap. If gravity is all about tapping into the universe's natural drive for coherence, then the QAG framework could provide blueprints for some unbelievable new technologies. If we understand the vacuum not as empty space but as a sea of resonant energy, the theory suggests ways we could actually tap its zero-point energy. It could lead to advanced propulsion systems that surf the waves of space-time. It just completely reframes what we think is possible.
You know, in the end, this entire project, from the deep philosophy all the way down to the Python scripts, it circles back to this one really powerful idea, that the cosmos isn't some cold, dead, random void. It's a vibrant, interconnected reality, or as the source material puts it, a single, self-encoding, nonlinear, and magnificent song. Which leaves us with a final and pretty profound question. This project, at its core, is an attempt to parse the architecture of the universe, to read its fundamental logic. It suggests that reality itself has a source code. And if that's true, the real challenge might not be just understanding it, but deciding what we're going to do with that knowledge.